Visible light contains a range of colors, but this range is only a small part of the entire electromagnetic spectrum. The rest of the spectrum is invisible to the eye, meaning we cannot see them, but they still exist above and below visible light. These components include gamma rays, X rays, ultraviolet, visible light, infrared, microwaves, and radio waves. The order is important because the spectrum is arranged in terms of relative frequency and wavelength. A useful way to remember the different components in that particular order is through a mnemonic device such as gate X usually lets in most radiations, where G stands for gamma rays, X for X rays, U for ultraviolet, L for light, I for infrared, M for microwaves, and R for radio waves. It is incredibly crucial that you remember the order of components in the spectrum because they are arranged according to their frequency and wavelength. Use the mnemonic. Imagine you're on the gate of physics heaven, and as the gate opens, it allows the heavenly visible light, along with all its family of radiations, to pass through. Of all the components, gamma rays is the most energetic, while radio waves have the least amount of energy. This means that gamma rays has the highest frequency and as a result lowest wavelength, while radio waves have the lowest frequency and the highest wavelength. I hope you remember the inverse connection between wavelength and frequency we discussed in previous session. So as we move from radio to gamma rays, the wavelength starts to decrease while frequency of waves increases. This is shown in the image below because as we move down, the waves are much closer to each other than before. We know that visible light forms only a tiny part of electromagnetic spectrum. The order of the spectrum is important because it arranges them in accordance with their frequency and wavelength of that particular wave. Highest and lowest energy waves are at the extreme. The mnemonic device is gate X usually lets in most radiations, with G for gamma, X for X-rays, L for visible light, I for infrared, M for microwaves, and R for radio waves. As we move from gamma to radio waves, the wavelength increases while frequency and energy of waves decreases. Conversely, if we move from radio to gamma rays, the wavelength decreases, frequency and energy of the waves increases. We know that when white light enters a glass prism, it splits into a spectrum of colors. The order of this dispersion of light is remembered through mnemonic device Roy G. Biv, with R for red, O for orange, Y for yellow, G for green, P for blue, I for indigo, and V for violet. Within this spectrum, red has the highest wavelength and lowest frequency, while violet has the shortest wavelength and highest frequency. So when we place visible light in electromagnetic spectrum, we need to be careful with Roy G. Biv. Red color has the largest wavelength, so it is closer to the radio waves, while violet has the least wavelength in visible spectrum, so is closer to gamma rays. Once we place the colors in the spectrum, we should note that the mnemonic Roy G. Biv reverses when applied from east to west. Due to arrangement in order of frequency and wavelength, Roy G. Biv transforms into Viv G. Yaw for order of visible light in electromagnetic spectrum. So we have two mnemonic devices, one for dispersion of light and second for order of visible light in electromagnetic spectrum. Shortcut to remember both is that one is the mirror image or reverse of the other. As they are part of a single family, there are certain properties that are common to all components of electromagnetic spectrum. All of them carry energy from one place to another. They are propagated by magnetic and electric field instead of atoms or molecules. As they are transverse waves, the magnetic and electric field oscillate perpendicularly to direction of wave travel and obey the wave equation. Moreover, they are transmitted, reflected, and absorbed. The interaction of disturbance between electric and magnetic field allows all of them to travel through space. all of the waves in the spectrum have the same speed, c, which is roughly 3 multiplied by 10 to the power 8. This is known as speed of light.